This lesson will cover the following topics. Operation of the ABS system. Precautions to be taken when carrying out a repair. Under conditions of good grip and during normal braking, the brake system operates without the intervention of the ABS system. However, during emergency braking, one or several wheels may lock. The computer monitors the acceleration and deceleration speeds of the wheel via the sensors. If braking regulation becomes necessary, the computer sends a command to the solenoids and activates the pump. The front wheel solenoids are controlled separately. The solenoids for the rear are controlled simultaneously. Let's start with the principle that the rear axle must be braked using a force which is lower than the force used for the front axle. The rear wheel solenoids are controlled simultaneously. The computer uses the electronic brake distributor logic to do this. The computer takes account of the information from the rear wheel that is turning the slowest. This computer function is called select low. In addition to lighting the brake lights under braking, the stop switch sends a signal to the ABS computer. The information from the stop switch allows the ABS computer to determine the start of braking in order to anticipate braking regulation. In the same way, when the pedal is released, the stop switch information allows the computer to quit an ABS regulation phase more quickly. Now let's look at braking without regulation. In the case of braking without regulation, the ABS unit does not intervene. The braking pressure is created via the hydraulic unit. At rest, the inlet solenoids are open and the outlet solenoids are closed. The increase in pressure takes place inside the circuit and builds up uniformly. Now let's look at the maintained pressure phase. The pressure in the circuit increases. In this case, wheel slip has a tendency to exceed the 20% threshold. The computer controls the closure of the inlet solenoid and isolates the master cylinder from the brake caliper. An increase in the braking pressure for this wheel becomes impossible. Now let's look at the pressure reduction phase. If the wheel starts to lock, the computer reduces the pressure for the wheel concerned. The inlet solenoid remains closed, the outlet solenoid opens and the pump is activated. The drop in pressure is instantaneous, thanks to the low pressure accumulator. The pump action allows the fluid stored inside the accumulator to flow back to the master cylinder outlet circuit, thus preventing the pedal from being depressed. The backflow causes the pulses felt on the pedal. Now let's look at the pressure re-increase phase. The outlet solenoid closes and the inlet solenoid opens. The master cylinder is reconnected to the brake caliper. Once again, the pressure increases and the wheel returns to its slip point. The faster the regulation frequency, the finer the regulation in braking pressure. Current systems can produce between 30 and 50 pulses per second. When the ABS system ceases to be operational, all the solenoids are deactivated and are automatically reset to the rest position. The conventional braking cycle is still active. Thus, the circuit pressure is directly sent to the brake cylinders. However, the driver must be aware of the consequences of driving without ABS or with the ABS system inoperative. In this section, we covered the following points. Under good conditions of grip, the brake system functions without the intervention of the ABS system. The computer takes account of the information from the rear wheel that is turning the slowest. The information from the stop switch allows the computer to quit an ABS regulation phase more quickly. At rest, the inlet solenoids are open and the outlet solenoids are closed. The computer controls the closure of the inlet solenoid and isolates the master cylinder from the brake caliper. During pressure reduction, the outlet solenoid opens and the pump is activated. During a re-increase in pressure, the outlet solenoid closes and the inlet solenoid opens. The conventional braking cycle is still active. Certain precautions must be taken when carrying out a repair on the ABS system. Check the condition and the cleanliness of the sensors, the instrumented bearings, and the targets. Check to make sure that none of the targets are damaged. Check the condition of the wiring and the cleanliness of the electrical connectors. Take care to follow the correct routing of the wiring and connectors. The reliability of the ABS system depends on this. When refitting the hydraulic unit, check to make sure that the brake pipes are correctly fixed and that there is no leakage of fluid. Also check to make sure that the wiring connection shows no traces of oxidation or of overheating. An operation on the ABS unit may require opening of the hydraulic circuit. It is necessary to bleed the brake circuit once the operation is completed. There are some special points to consider in the procedure for bleeding a brake system equipped with ABS. In addition to the usual bleed operation, there is the additional bleed operation for the hydraulic unit and its various circuits. The bleed operation for the ABS unit may require the use of clip to open the hydraulic unit solenoids to evacuate the air. The bleed operation for a conventional braking system without ABS consists of bleeding in the following order: the rear right-hand wheel, the front left-hand wheel, the rear left-hand wheel, and the front right-hand wheel. Certain models equipped with ABS require the bleed operation to be performed in a specific order to facilitate the hydraulic unit bleed operation. Please consult the technical documentation for details of the correct bleed procedure and the special tooling required. In this section, we covered the following points. When carrying out a repair on the ABS system, check the condition and the cleanliness of the sensors, the instrumented bearings, and the targets. When the hydraulic unit is refitted, the brake pipes must be correctly fixed and there must be no leakage. There are some special points to consider in the procedure for bleeding a brake system equipped with ABS. Certain models equipped with ABS require the bleed operation to be performed in a specific order to facilitate the hydraulic unit bleed operation.